So we are going to finish off 6.4 with simplifying complex fractions. Um, so it's going to be using a bit of everything that we've used from adding, subtracting, and dividing and multiplying fractions, complex fractions, or rational expressions, sorry. So here, it's called a complex fraction because obviously it looks pretty complex, right? So we have this numerator, which is a rational expression, and then in the denominator we have two separate rational expressions being added. Okay, so this is why it's called complex. Now, you have to do these in a certain order if you're going to get the most simplified expression correctly. So start with what you have in your denominator or in your numerator. If you have adding or if there's any sort of adding and subtracting of two or more rational expressions, start there. So here we just have this one rational expression in the numerator, but in the denominator we have multiple rational expressions. So take care of that first. You're going to want to do that first, or else you're not going to simplify. Because sometimes I think I'm not entirely sure if this doesn't work, but it might be students' first instinct would be to use the keep, change, flip rule here, or the division property of rational expressions, which is to keep this right here, flip this, and multiply by the reciprocal, so x plus 4 over 1 plus 2 over x. But again, I'm not entirely sure if that doesn't work, but I don't think it would. Because I think you need to simplify this or add these together before you can do this rule. So let's tackle what we have in the denominator here. Okay, so this right here should just look like what we've been doing in the previous examples. So I need to get a common denominator here. Now, the factors in this denominator consist of x plus 4 and x, which means that I need to multiply using the least common multiple method. Just multiply, or I guess in this case we're just going to be using the definition method as because they are the same thing here. But I need to multiply this by x plus 4, and this by x plus 4, this side by x over x. And when I do so I'm just talking about the denominator here. So then I get 1 times by x on the left, and then plus, and then if I distribute that, I get 2x plus 8 on the right side. And now that they have common factors, I can just list it as one denominator. So x times by x plus 4. And then this is equal to 3x plus 8, and then over x times by x plus 4. So let's rewrite what our expression looks like now. So on the numerator, I had 5 over x plus 4 divided by 3x plus 8 over x times by x plus 4. Now that I don't have any sort of two rational expressions being added in the numerator or the denominator, now we can use our division property of rational expressions. So I can keep the first expression, so 5 over x plus 4, change the sign to multiplication and flip the other expression. So now it's x and x plus 4 over 3x plus 8. And then when I multiply them, I get 5 times by x plus 4 over x plus 4 times by 3x plus 8. And then you can see that I can get rid of these, divide out these common factors. So that will be left with 5x over 3x plus 8. Okay. And that's pretty much it right there. So that's all you got to do. It's just using everything that we've learned. Okay, now down here, I can, I'll do one of these ones right here. So this one doesn't seem too bad. I'll leave this one for you because that seems like a challenge. And why not? So here, notice that I have rational expressions of addition and subtraction on both the numerator and the denominator. So we have to do it, let's start with the numerator and simplify the numerator, and then we'll simplify the denominator. So this is the same thing as 3 over 1. So to get a common denominator, I'll multiply this by 10 and this by 10. So I get x minus 30 over 10 divided by, and now this side of the expression right here, now this is over 1, so I multiply this by x and this by x. I get 5x plus 1, so I don't need to multiply this by anything because it's just x, over, and then x. And now that I've gotten rid of these adding and subtraction of rational expressions on both the numerator and the denominator, I'll take my top expression, so x minus 30 over 10, keep the first, change the sign, flip the second, just like that, and then this is equal to x times by x minus 30 over 10 times by 5x plus 1. Okay, now looking at that, I don't know if there's anything that we can really do to factor that anymore, because I don't think we can factor this anymore. I don't think we can factor that anymore. So I think that's pretty much it right there. We can't cancel anything out, and that's fine. That's totally fine. Okay, now that should wrap it up for all of 6.4.